observatories around the globe turned their mirrors toward it. Calculations came swiftly. The trajectory was hyperbolic, its velocity nearly 60 kilometers per second. This was no returning comet. It was an interstellar intruder. They named it 3I Atlas, the third confirmed visitor from beyond our solar system. But as its image sharpened and its path grew clearer, the data began to whisper something more unsettling. The object's brightness fluctuated in irregular rhythms, its albedo shifting like a heartbeat of light. One moment bright as fresh ice, the next dim and muted. It seemed to tumble in unpredictable patterns, spinning through the black like a shard of mirror adrift between suns. Spectroscopic scans revealed compounds unfamiliar to solar system chemistry, a spectral fingerprint laced with carbonaceous silicates and volatile ices, but in ratios no known comet could sustain. It was neither fully rock nor ice, but a hybrid of both, a cosmic paradox frozen in motion. Its surface reflected sunlight in pulses that defied rotational logic, as if its facets themselves were rearranging. Astronomers across continents debated in silence and wonder. Was it a fragment of a shattered exoplanet? A remnant of some long-extinguished system? Or something shaped, intentionally or by chance, to endure the cold violence between stars? Theories multiplied as rapidly as the data streams. Its light curve hinted at non-uniform geometry, and its photometric pattern refused to settle into predictability. Even the thermal readings carried contradictions, temperatures that rose without cause, then dropped without correlation. The object's journey traced a path older than the sun itself. It had crossed interstellar dust fields, endured radiation storms, and wandered the void for millennia before reaching this brief encounter with humanity's gaze. And yet, in the vast chronicle of space, its arrival was instantaneous, a fleeting anomaly, here and gone within months. But as observatories refined its orbit, a deeper mystery emerged. The numbers didn't align. The trajectory curved too sharply. Its deceleration near the sun was weaker than gravitational models allowed. Something else, something unseen, was influencing its course. The laws of Newton trembled at the edges of their certainty. The universe, once again, refused to behave as expected. Somewhere between the equations and the light, a hidden force was at work, one that would soon reveal that 3I Atlas was not merely passing through, but demonstrating a physics no one yet understood. On the seventh night of continuous tracking, something subtle began to emerge from the stream of measurements. The faint interstellar traveler, now firmly catalogued as 3I Atlas, refused to obey its own orbit. With every update, its path deviated just enough to disturb the equations, small, almost imperceptible shifts that no gravitational model could explain. By all classical laws, its motion should have been predictable, smooth, and unyielding. Yet the data showed a persistent anomaly, an acceleration away from the sun. The numbers were relentless. Millimeters per second compounded over days became kilometers per hour over weeks. The pattern resembled the non-gravitational accelerations seen in comets expelling vapor, yet 3I Atlas displayed no visible tail, no jet, no signature of sublimating ice. Its coma was faint, its thermal emission inconsistent with active outgassing. The standard explanations, radiation pressure, mass loss, thermal recoil, each collapsed under scrutiny. The force was there. Its cause was not. Photometric readings deepened the mystery. The object's brightness oscillated with complex periodicity, cycling through variations every few hours. But these cycles didn't align with a simple spin. Instead, they followed harmonic patterns, second-order fluctuations within the broader light curve. Something in its surface properties was shifting, perhaps melting and refreezing in sync with rotational exposure, or reflecting sunlight through a geometry too intricate for simple cometary behavior. At the University of Helsinki, analysts noted microfluctuations in the light curve phase, a phenomenon resembling polarization drift, as though light scattering across its surface was being modulated by changing reflective properties. That modulation hinted at a layered structure, or thin films responding to radiation pressure in ways never seen before. A few voices dared to ask whether such structure could be natural at all. Then came the thermal paradox. As 3I Atlas neared the inner solar system, its surface temperature behaved erratically, rising faster than the solar flux could justify. It emitted infrared radiation far beyond its energy intake, as though heat were being generated internally or through unknown photonic processes. The more data scientists collected, the less sense it made. Theories fractured into boldness. Some proposed fractal outgassing, volatile release through microscopic pores invisible to telescopes. Others invoked ultra-thin materials, perhaps less than a millimeter thick, able to harness solar photons as thrust, a natural photonic sail formed in deep space. The probabilities were infinitesimal, yet the fit to the observed acceleration was unerringly precise. The cosmos seemed to have presented a riddle wrapped in its own laws, a traveler propelled by forces beyond conventional comprehension. The data refused dismissal, every variable ruled out, every constant shaken. The equations could describe what it did. None could explain why. If not gravity, and not chance, then what invisible hand was guiding this object through the void, and what might it reveal about the unseen engines of interstellar space? It was not the first time the cosmos had whispered of impossible motion. In 2017, the discovery of 1I Oumuamua had ignited the same tremor through the scientific community. A slender, tumbling object from interstellar space that refused to behave as celestial mechanics demanded. It accelerated without visible thrust, shone without uniformity, and vanished before full understanding could take hold. Now, 7 years later, the pattern had returned. And with 3I Atlas, the universe appeared to be repeating itself, or continuing a story left unfinished. Across observatories, astrophysicists reopened dormant datasets from Oumuamua's fleeting visit. They compared light curves, reflectivity gradients, and acceleration ratios. To their astonishment, a quiet resonance emerged. Both interstellar bodies exhibited similar non-gravitational accelerations, not random, but proportional to their proximity to the Sun. It was as though each responded to starlight itself, obeying a rule hidden within the photon's pressure. The correlation was too precise to dismiss as coincidence. In Cambridge, a team led by orbital dynamicists recalculated Oumuamua's spin evolution, overlaying it with 3I Atlas's data. Despite their differences in size and shape, the patterns aligned, a synchronized rhythm between brightness fluctuations and trajectory drift. It was as if both objects were crafted, or eroded,